Hello guys, I can't hear you, so I'll just try to continue. The network this side, you can see it's not strong, but I will continue, try and see what will happen better. There's no network this side. If we don't manage each other, maybe I will send another link for early morning before 5 or somewhere there, because I can't hear you. I'm just talking alone here. Myself, I can't hear you. I can't hear you this side. So that is the challenge. How can we work yet we can't hear one another? Because I wanted to do partial fractions, an activity on partial fractions for today, just for the start. But I can't hear you. Integration by partial fractions. The challenge is the network this side. You can see from the screen it's very poor. Very poor. Network is very poor. But to manage. If you are saying you can hear me that side, let me try to just do something, but we'll see if I'm audible that side. Side I don't work. I hope you can hear me. All right. So I was saying that when you're integrating by partial fractions, like for example, we are given an integral, like which is on the screen. You want to integrate by partial fractions. So I was explaining, then that's when I realized that I'm talking alone. I don't have an audience. The network is poor. But you guys are saying you can hear me that side. I can hear you, but I can't hear you back. I'm talking alone. If you didn't understand anything, how am I going to explain? However, maybe the recording will help us. So if you are given an integral I is equals to the integral of x squared plus 2x minus 1, x squared plus 2x minus 1 over the denominator 2x squared plus 2x cubed plus 3x squared minus 2x. So first of all, you must factorize the denominator. That is the hint when you are factorizing, when you're integrating by partial fractions. You must check the degree of the highest on the numerator and the degree of the highest polynomial on the denominator. So you can see that the denominator is smaller than the numerator is smaller than the denominator. So which means in this case, we can't use division because already the numerator is smaller than the denominator in terms of the degree of the polynomial. Therefore, we must factorize our denominator so that we can split it into partial fractions. So in this case, if you want to factorize that, we can see that x is common in all the terms. In this term, we are having 3 terms. So when you factor out x, we are going to be left with 2x squared plus 3x minus 2. Then this is a quadratic equation. This is a quadratic equation. So you factor it how? You know 2x by 1x, it will give you what? By x. 2x by x, it will give you 2x squared. And the combination that will give you the middle term, which is plus 3x, is going to be which two numbers, which you are going to multiply. So we are going to say 4x, after when you cross multiply this side, you are going to get 4x. So 4x minus, then you cross multiply that side minus x. That's where this 3x is coming from. So the combination has to be 2 minus x and x plus 2 for you to get that term. So you must be able to factorize that expression from grade 12 mathematics. Then from here, once we have factorized the partial fraction, I mean the denominator, now we have to express each and every term of these denominators, which we have found here. So we are going to split into different fractions having this denominator so that we can integrate easily. So when you use our formula here, we are going to say that the numerator that we are having here is x squared plus 2x minus 1. Then now this is our new denominator, which means now instead of writing this as the denominator, instead of writing that as the denominator, now we can replace that with this new denominator. That is the new denominator that we are going to be using in this case. So once we know all the denominators, x, 2x minus 1, x plus 2, we introduce what we call the constants a, b, and c. We want to know what are the values of a going to be, what are the values of b going to be, etc. and etc. So now we have to find, we look for the values of a, b, and c. So in other case, we are saying, let's solve for the constants, which we want there. We want to solve for a, b, and c. So we equate the numerator to a, b, and c because already the denominators is fine. So what we are equating is the numerator a, b, and c. So in other words, you are saying now, this x goes into this expression how many times? So we are saying x goes into this expression how many times? So this x and that x, they will cancel. That's why we are left with this part, which is just 2x minus what? Minus 1 bracket x plus 2. Okay. That's why we are left with that expression. Then you come and say x minus 2, this one, goes into this expression how many times? So this and this, they cancel, meaning you are left with x bracket x plus 2. So b multiplied by bx bracket x plus 2, it will give you bx bracket x plus 2. Okay. And then from there, we also go to x plus 2. X plus 2 goes into this expression how many times? Which means this x plus 2 will cancel with that x plus 2. Then you are left with cx bracket 2x minus 1. So what is left now there is for us to equate the constants. Now we are left with equating the constant because this expression now we know where it is coming from. Okay. So you want to equate the constant so that you can solve for a, b, and c. So if you want to solve for a, b, and c, you are going to use elimination. In this case, if you let x equals to minus 2, which means you are going to be left out with these two expressions. They are going to vanish. If x is equals to minus 2, if x is equals to minus 2, which means you are only going to be left with cx 2 bracket x minus 1 is equals to that, which means a and b, they are eliminated. Now you can solve for c. So that's how you'll be using. You'll be using elimination, whereby you'll be solving for the unknown c, in that case, which we are having. Okay. Then let's see what is it that we have solved. So in our case there, we expanded the bracket. Then after expanding the bracket, it makes it easy to equate the coefficients which are inside. Because if you don't expand, how are you going to equate the x squared to the x squared to the x, 2x to the x? So we have to expand so that it's easy to equate these values. All right. So from there, let's see. Let the screen open so that we can continue. But myself, I can't hear you from this side. I'm just talking alone here. I'm just talking alone. However, let's continue. Maybe the recording will work. All right. So from this step now, we can also let x equals to 0. By letting x equals to 0, which means we can eliminate this one. We can eliminate letting x equals to 0. We can only eliminate letting x equals to 0 can only eliminate some certain values, not the whole expression. Or in this case, if we let x equals to 0, c will vanish and b will vanish because x is equals to 0. So you can solve for what? For a. And if x is equals to 2, negative 2, like I indicated, x is negative 2, which means this will vanish, negative 2, and this will be 0. And this will be 0. Sorry, this will be 0. So which means you can solve for c. And if you let x equals to 0, you eliminate b and c, then you can solve for a. So that is the strategy that we'll be using when you're solving for partial fractions, integration by partial fractions. Right, so let's go. Let x be equals to 0 in our case, which means this term is going to vanish, this term is going to vanish. X is equals to 0, which means we are only dealing with a. So the term that we are only interested in is this one. We are only interested with that. So if x is equals to 0, then we equate to those coefficients. So when we equate to those coefficients, we solve for a. So in other words, when you expand, you are going to equate 2x squared, like that. 2a x squared is equals to x squared, like that. And then you want to solve for a, which means you are going to divide both sides by what? You are going to divide both sides by x, 2x squared. So when you divide by 2x squared, which means 2x squared, and then also this side you divide by 2x squared, and then they cancel. Then you are left with half. That's where the a half is coming from. Okay, that's where the a half is coming from. Okay, I'm seeing a message there. Say I can hear you. Okay, fine. Let's continue. And then now we can solve for c by letting x equals to negative 2. So if x is negative 2, now we can solve for c. Why can we solve for c? Because we have eliminated b and what? We have eliminated b and a. These are out. So these are out. Now we can solve for c. So when you expand that bracket, you can see that saying 2c x squared, 2c x squared should be equals to what on the other side? So which means minus cx is equals to x squared plus 2x minus 1. So you equate everything that is having the x. Right, so let's continue from there. So the a, we have solved it. Now we are going to solving for c, where they is saying x is equals to negative 2. And where is minus 1 and 10c coming from? So that is where we want to use and we see where did we get -1 is equals to -1 is equals to 10c, and c is that. So that is what we want to solve for. Okay. So we have said our c, when we let x equals to 2, so which means letting x equals 2 makes this to vanish. X equals to 2 vanishes. This vanishes. Okay. So now you are left with cx squared. So you write your 2cx squared minus cx is equals to x squared plus 2x minus 1. Meaning that you are equating the x squared to the x squared. So in that case, we know what is the value of x. It's 2. So the value of x is 2. So which means 2 squared. What are we going to get with -2 squared? We are going to get 4. So -2 squared is 4. And then 4 times 2, you equate also to the other side. So in other words, what we are having there, when we expand the bracket, all the values that we are going to be getting, for example, when you factor out c, two c bracket. Now you are left with what is inside the bracket, 2x squared. And then minus